All right, hi there again. This is the Chapter 5 review video for the proof. So the first 6 questions were true, false. Remember, read them carefully. Look at your properties. Okay, and if it's true always, it is true. If it's true depending on this or that, then it's false. So be aware of the true false. Again, the big picture is get an equation from the facts of the quadrilaterals. In problem number 7, it was the upper base angles are congruent to get the equation. In 8 and 9, these are crook problems. Draw auxiliary lines, and don't forget to see the various transversals, okay? So this is a transversal, all right? This is a transversal. They're separate, see? This is a transversal. Here we have another transversal here. And finally, the last transversal in this problem would be there. So see those transversals. Problem number 10 is alternate interior angles are congruent, where you're going to add angle 2 and angle 3. And problem number 11 is a ratio. So that ratio is evident here. And solving for x gives you the answer for x, but you have to answer the question. Okay, so you have to, in problem number 12, you have to use the facts of a kite to find the perimeter and 2 distinct sides congruent. Diagonals are this diagonal is split into 2. The smaller diagonal is split into 2. The larger diagonal actually bisects the angles, but you're not needed in this problem. But it is the larger diagonal that bisects the smaller diagonal, making the smaller diagonal 2 equal parts. And then we did the proof, and you were given it's a parallelogram, so we got these 2 triangles congruent by angle, side angle, and then we proved by CP/CTC that those other 2 parts were congruent. We used if parallelogram twice. Problem 14 proof, what we're going to do for this one is, we'll take a look at it again. There's a couple of ways to do this, but what I'm going to do is I'm going to get these small triangles congruent. Now, there's another way to do this proof by getting these 2 triangles congruent. So this one and this one. So you can get this side congruent to this side by CP/CTC, and then you can get these 2 sides parallel by angle 1 and angle 2. Actually, you know what? Now that I think about it, I think I'm going to do that proof this way, okay? Because we're given AE and CF, see? We're given AE and CF, and then these 2 here by addition. So I think we'll do that, okay? And then that way we don't even need the parallel lines, okay? So, yeah, we do. Wait a second. I'm confused. Okay. Okay. So what we can, since we're given this, okay, so we got to use this. And this is the hard part of this proof. We got to use this and this are parallel, all right? So what we'll do for this proof is we will get this angle congruent to this angle by alternate interior angles, because these 2 are parallel. And then we will get the 2 triangles congruent by angle, side, okay? And then we'll get these 2 congruent by CP/CTC and these 2 parallel by alternate interior angles, because angle 1 and angle 2 are congruent, okay? So we've got to use all that. So we're going to get the 2 big triangles congruent in this proof, and we're going to use those 2 parallel. We're going to use DE is parallel to BF, and then we're going to use this angle and this angle as alternate interior angles. Okay, so let's go ahead and prove that. And I'm just going to lump these three givens together, okay? So angle 1 congruent to angle 2. AE is congruent to CF. And, excuse me, DE parallel to FB. Okay? And that's given. All right. So now what we want to do is I'm going to get, I will kind of erase it here, but I'm going to get AF congruent to CE by addition. Okay? So number 2, AF congruent to CE by addition. Okay? Now, here's the hard part of this. It's these two angles. So it's BF, is that an F? I covered it up. BFA congruent to CED, because if parallel, which we have right here, then the alternate exterior angles are congruent. That's the, see, these two parallel, not exterior, these are interior. Interior, okay, angles congruent. So those are interior there, okay? So those are congruent. Now, we have the two triangles congruent. Triangle BFA, I'm just stealing these three letters, triangle BFA congruent to triangle CED, and I believe it was angle side. Now the first angle was 1 and 2, so that's 1, okay. This second angle was 3 from the alternate interior angles. And then the side we had was 2 by addition. Okay? Now, excuse me. We have AB congruent to CD by CPCTC. So AB congruent to DC, and that's CPCTC. Now, we can also get AB parallel to DC. Now, why is AB parallel to DC? Well, AB is parallel to DC because angle 1 and angle 2 are alternate interior angles. Okay? So, the reason for that is if alternate interior angles congruent, then we have parallel lines. Okay? And that's it. Because we have one pair of opposite sides congruent and parallel. That makes ABCD a parallelogram. ABCD is a parallelogram. And the reason is if one pair of opposite sides, and that's AB and CD, one pair of opposite sides are congruent and parallel, then we have a parallelogram. The quadrilateral is a parallelogram, okay? Now, CPCTC, got to fix that. I think I don't like the order of these letters, BFA and CED. So BFA, CED, yeah. So it should be BFA, BFA and DEC. And that way we can say that AB is congruent to CD. I just like that better. And then AB parallel to CD. Okay, just the ordering, right? So because we're going from here to B, so we have to go from up here, which is the angle, to D. So C to D and A to B. So I'm just, anyway, that's it. Have a good day.